Settle down, settle down. So I'm Jonathan Roeder, this is my partner, Ryan Rozich. We're excited today to talk about Magento's data-driven future. We work for the data solutions organization within Magento that works within the Magento Product Organization. We've been around for about a year, and in that year, our mission has been to begin enabling our merchants, our customers, to create intelligent experiences and uncover commerce insights with data field capabilities. And so to that end, we have responsibility for the product roadmap and execution of Magento Business Intelligence. Anyone use that? Familiar with that? There we go. And then any Sensei AI machine learning capabilities, we'll talk about those. And then also, because it is, since it is intelligent or needs to be, our storefront search capabilities. So, luckily we don't have to do this alone. We work in partnership with Adobe Research and a number of other organizations. I'll mention Adobe Research and one more. Adobe Research is an Adobe-wide org, so it services all of Adobe. It has hundreds of research scientists, engineers, artists working in collaboration with academia. They're trying to understand, anticipate, and invent the future, and then turn around and work with product teams like ourselves, and then drive that into our products. So really exciting to work with them. And then also, if you heard Peter speak this morning, he mentioned Adobe Sensei. It's the underlying platform that we all use. It's very difficult to productionalize AI systems. So this is a set of technologies and teams that help us make that possible. If you think about Adobe, you can think about three big legs on the stool. On the creative side, you have obviously Photoshop, Illustrator, etc. Our pedigree with PDF on the content side, and then last and hopefully not least, the creative side where Magento resides. In each of these areas, you can see that Adobe's adding intelligent capability. And what's really exciting is if we have innovation that is applicable to the creative side, through our partnerships with research and others, we can actually go pluck that and bring that over and apply that on our side of the house. So the network effect of working at Adobe. So with that background in mind, we'd like to kind of take you through some concepts in artificial intelligence, maybe demystify it a little for people that aren't as familiar, and then discuss how we're actually applying it. So when I talk about artificial intelligence, when I talk about intelligent systems, I'm really talking about machine learning. But what does that mean? What's machine learning? So here's a somewhat helpful definition. So the ability of a machine to learn from experience instead of being explicitly programmed. Was that a helpful definition? Maybe a little bit. So we'll dive a little further down. So there are three main subfields of machine learning. Unsupervised and supervised I'll discuss, and then Ryan will talk a little bit about reinforcement learning. But it's really important to note, I'm going to use the word learn and perceive and experience. And this all connotes a certain kind of human cognition, a certain intelligence that, like we have. And it's really early in the artificial intelligence space to think that way. So what we're all shooting for is some amount of competence. We want to build systems that are competent. We don't expect them to be able to really comprehend what's going on. That's further along. That's the study of artificial general intelligence, which is beyond what we're trying to focus on. Okay, so let's dive in. So supervised learning. So let's say that I want to teach a machine how to understand what a cat looks like, right? So in order to train a machine to learn that, or learn a machine to know what cats are, I need to feed in examples of cat pictures, right? And I have to add labels or ground truth data. So I have to actually feed in a bunch of pictures that clearly say this is a cat. And then I need to feed in a bunch of pictures that clearly say this is not a cat. And the machine learning occurs because the machine decides what aspects of each picture are cat-like versus not cat-like. That's where the learning occurs, right? But in order to achieve that, the machine has to be told the ground truth. Cats, not cats. If we compare that to unsupervised learning is an approach where you feed in data, and it's not ground truth data, it's data. And then the machine can tell you interesting things about that data. So for instance, you can feed in a bunch of traffic, and then a machine can do anomaly detection. This traffic looks like it doesn't fit the pattern. Or you can feed in a bunch of user profiles, and then the machine can generate clusters of similar users, right? And then you can go and investigate what are the aspects of those users that are unique to that cluster. So So supervised learning, by comparison, as we discussed, it requires ground truth data. The reality is the majority of the machine learning solutions that we have in place in production today are supervised. I think when people think about machine learning, they might think about unsupervised systems where you just put data in and the machine figures stuff out. But that's really not the case. And so the implication is that we need to curate large sets of truth and then feed that in and have the machine learn it. And so that actually ends up being part of one of the challenges of machine learning is finding that data or creating that data, curating that data, and making sure that it's correct. Okay, so let's dive a little deeper. We're going to mostly talk about supervised learning now and some particular areas of focus at Adobe Research that I think we can think about ways to apply to commerce over time. So natural language processing is a subfield of machine learning focused on understanding what it is us crazy humans say. So understanding language. When I'm sure you've all possibly used like a translation system that's taken English and turned it into Spanish. Those systems are using natural language processing in order to achieve those translations. And there's been an incredible improvement in those systems in the past 15 years. If we try to liken examples to commerce, obviously we all have Siri or Alexa or Hey Google, how you doing? And so each of these systems now let us attempt to converse with them. And natural language processing tries to understand what we're saying and then turn that into understanding and intent. And so as conversational commerce starts to become more commonplace, it'll be important for all of us to have natural language processing capabilities to enable that. Likewise, if we think of an example of customer reviews, let's say that a shopper is viewing a website, they can see a number of reviews for a product and determine if they want to purchase that product or not, certainly part of how I shop. But what if we use natural language processing to read the reviews for us and then to summarize, to provide the gist of the positive statements and the negative statements. So if we trusted the machine to understand enough, it could then actually summarize, generate content for us, which is exciting. So in the computer vision space, there are, obviously Adobe focuses very heavily on this since we have such a pedigree in the creative side of the house. Thinking about commerce, a naive approach to computer vision might be to take this image on the left for a particular product and figure out what colors are part of this image and then attribute that to the product. But if we understood that the product for sale was actually a shirt, the computer could see the shirt amongst the other colors and then detect the actual color of the shirt. Likewise, visual search, right? So everyone's taking 1,000 pictures a day. Everyone's using Instagram or Pinterest. You're wanting to look at something and then find something similar to that online without having to type in words and search for it, right? A picture's worth 1,000 words. Can't I communicate with the system using pictures? Well, that's certainly a possibility. And so image search will find products, images similar to what you upload, and then can also find other products that are visually similar to the one that you're looking at. Lastly, for me, take a look at these images. What do they all have in common? Nobody? So these are all examples of deep fakes. None of these are real. The cats are not real. The humans aren't real. Computers have generated these images. The implication for commerce is obviously it's a visual, immersive experience. We can actually start to automate the creation of imagery, of videos, of audio, and we can actually personalize that to individual shoppers. So if we take a step back at what we just kind of shotgun through, on the consumer side, by applying machine learning, we can interact with consumers in ways that are more natural. So we can understand what they're saying and what they're seeing. And then on the merchant side, we can make better sense of our data, and we can actually harness and create content in the future.
So one of the biggest questions is, with serving these machine learning and AI-based experiences, are these making a meaningful difference in revenue, sales, lifetime value of the customer? And many of you are probably familiar with A/B testing. Do you guys do A/B testing today? So several folks. And indeed, A/B testing is the gold standard when it comes to measuring cause and effect and figuring out how much things are moving the needle, but it's not without some challenges. So let's take a look at a quick example. So now that Jonathan's a supervised learner can tell the difference between cat and not cat, we're left with the question, which one should we put on our homepage? And so the typical approach to this is to split the traffic 50-50, and then go to our statistician who tells us to get statistically significant results, we need to use an A/B test covering 50,000 visitors. That's going to take us 5 days to run. So we let the experiment run, and we learn that the picture of the dog has twice the conversion rate of the picture of the cat. And we declare that the winner, and that goes on our homepage. But the problem here is that we've just spent 5 days serving half of our audience a non-optimal experience. Essentially, we've left money on the table. And what if we wanted to not just test 2 images, but test 4 images? Then we'd be serving that for 10 days. Or if we had half the traffic, we could be spending a long time, and this is a real opportunity cost for us. And so that's where more advanced testing like multi-arm bandits come in. And multi-arm bandits start to not just explore the space, get an answer, and then exploit the results, but they can both explore and exploit at the same time. These algorithms can start to shift traffic over to variants that it has more and more confidence that are going to win before the experiment is actually complete. So as I start to learn more and more that the dog pictures has a higher conversion rate, more and more of the traffic will move over there. Adobe Target has a feature in its testing system called Auto Allocate that will implement some of these multi-arm bandit type tests. But then the question is there really a winner here? I mean, intuitively you might think that dog people might have a higher affinity towards the dog picture, and cat people might have a higher affinity towards the cat picture. Or maybe the hour of day makes a difference, or there might be seasonal effects of when certain images do better than others. And contextual bandits can start to take the context, the user context, their situation into account, and start to find the optimal variant for different contexts. And Target has features built in to auto-personalize using contextual bandits. So these bandit-based systems are very simple implementations of reinforcement learning. Our group works very closely with researchers at Adobe Research that focus on reinforcement learning. And this is somewhere in between supervised and unsupervised learning approaches that Jonathan talked about earlier, where the system learns the right actions to take based on experience interacting with an environment. And so computers have been taught to play video games just by pointing a camera at the video game and letting it take random actions till it learns how to get the highest score. You're probably familiar with the self-driving cars who learn from taking actions in the world. And in our space, we start to think about using this type of technology to build the self-driving site. So this is a picture of my Amazon homepage. And if you're like me, it always feels a little bit jarring to see somebody else's Amazon homepage. It's kind of like getting a little bit of a window into their personal preferences. It's even worse when you see like their Spotify recommendations or playlists. But for the person using Netflix, this is a very comfortable experience. A lot of people go home and open up their Netflix home screen and not know exactly what they want to watch, but know that they're going to find something very quickly. And so the question is, why can't our shopping experience be like this? Every part of this experience is data-driven based on my consumption behavior. From the hero carousel at the top to which rows of recommendations show up for me and in what order, to the individual shows that are recommended within each row and the orders those show up, to the display formats, whether they're tall or wide, have autoplay features, to even the fan art that shows up, to the images for each show. So Netflix is generating lots and lots of these images, and so sometimes you'll notice when you go that the fan art looks differently. They're actually testing out different configurations and learning what resonates with you. And this isn't just Netflix. And in addition to being merchants, we're all shoppers. So we know that shoppers are surrounded in their everyday online experience with these self-driving capabilities, whether it's how they connect with their friends on social media, to how they consume news, to media, to shopping. And we also know that personalization is becoming increasingly important in e-commerce. 68% of shoppers report that their purchase decisions are based on personalized experiences. And even Amazon reports that at least 35% of the purchases that are made on Amazon come directly from product recommendations, algorithmic, personalized product recommendations. So there's not many tweaks or widgets that you can throw on your site that gets this type of performance. And so kind of transitioning to what our teams are building right now, when we talk to merchants and partners about the wide range of things we could deliver into the Magento product, it wasn't surprising that product recommendations was reported as being sort of the no-brainer, as sort of the top of the priority list. So let's talk about what the team's working on right now. Many of you are probably aware of the current capabilities that are in Magento. So you can go and create manual associations between products. In Magento Commerce, you can actually create rules for how products should show up in related products, cross-sells, or upsells. And these are extremely powerful, but it also requires the merchant to have sort of an intimate understanding of the relationships between products, to maintain those relationships as new products are introduced. And so, we're very excited to be building the first AI and machine learning feature into the Magento platform. Product recommendations powered by Adobe Sensei marry the deep commerce expertise of Magento with the vast AI capabilities at Adobe. When this is released out of the box, Magento merchants will be able to deploy recommendation units on key parts of their site, like product detail pages, shopping cart pages, and home pages that are based directly on consumer interaction behavior. This will be delivered for all Magento merchants. It'll come with Magento Commerce, and it'll be delivered as a SaaS service. So let's take a quick look under the hood, how this will work between the Magento instance and our SaaS service. You'll install a Magento extension into your storefront. So the two key ingredients for how these recommendation algorithms will work are shopper behavioral data and product data. So this extension will install a JavaScript beacon onto the storefront, which will send us anonymous shopper behavior, such as product views, adds to cart, and purchases. And the catalog sync process will sync catalog data. So product metadata, attributes, price, availability, and inventory. Adobe Sensei algorithms will process all of that data, turn it into machine learning models that are deployed as a SaaS web service. And then in real time, as the shopper is browsing the site, it will request those personalized recommendations from the SaaS web service. We expect this feature to begin early access program by the end of this year. We already have a handful of merchants who have deployed the extension and are starting to send us training data on which these models will be built. And so if you or anybody else is interested in being part of the early access program, please feel free to follow up with me, and we'd love to talk to you about that. So thanks for the time. This is all we have today, and we'll take some questions. Yep. That's right. Yep. It'll be included. Yeah, in the license fee. That's right. Yep. The question is this included in the commerce license? So we just switch it on, and the answer is yeah. Yep. Well, for the early access program, we're looking for 2.3 merchants. Yeah.
So when it comes to the particular recommendation capabilities that we're talking about, it'll work a little differently. It's going to be powered by what shoppers actually do. When it comes to the other examples I was providing, the machine learns based off of what the ground truth it's fed in, and so it is dependent upon how people see and describe that data. When it comes to scenarios where we're wanting to take AI capabilities and apply them into commerce, that's where we're needing to be careful to make sure that we bend those capabilities to where they're commerce specific. A simple example is a natural language processing system that could take the words I'm speaking now and turn them into text. One of the big companies like Google or Microsoft tried to deploy it for drive-thrus. And people would pull up to the drive-thru and talk to it, and it couldn't understand because the data hadn't been put through. The audio that had trained the system didn't sound similar to the audio that you hear through a drive-thru window. So we have to be really careful and eyes wide open about how we train these systems.
Sorry, the third part is you recognize some of these recommendations not really a perfect system. Because like you mentioned the Netflix thing, and sometimes I see the Netflix, like you're so off-base of your recommendations. Or with music, like why would I listen to Imagine Dragons or listen to the Black Keys? I would never listen to Imagine Dragons if I was Black Keys.
I'll say one thing. These systems are certainly imperfect, and it's very, like, there's a lot of good progress being made, but it's still very early. Also, there is exploration that happens, and so by putting noise in and seeing if you don't listen to the Black Keys, for example, then it could then learn that, okay, that was wrong, so.
Yeah, there's different options available. So essentially when you create one of these recommendation units, you can say what type of recommendations do you want to show. So very simply, you could say like, I want to show the most popular things. The machine doesn't know that the most popular things. It's like you're making the choice to do that. But we will have some sort of pre-configured sort of best practices around saying like at the bottom of the product detail page, it's great to show up people who viewed this also viewed that, or these things are frequently bought together. Over time, we may have machine learning that learns the optimal configuration for a user, but for the first version, we won't have that.
You have those manual sort of rule sets now in commerce. Will the Sensei recommendations play alongside that? Can they play alongside that? What's the direction? Are those and or perhaps feeding recommendations? We have a pin, and we have a legacy of product experts that recommend products that are natural upsells and cross-sells.
Yep.
Can you play with, how does it work?
Yep. So the question is, can the related product rules coexist with the Sensei AI-powered recommendations? And the answer is yes. So there'll still be related product rules, the ability to do everything you can do today by creating rules and manually tagging associations and building things that way. You will also be able to set filters. So if there's business rules that are sort of more coarse-grained, like never recommend anything under a certain price, obvious things like maybe I don't want to recommend things that are out of stock, and so on. You'll be able to apply those as sort of a constraint on the AI rules. Yes. Yeah, that's an area that we're collaborating with research on to build. That won't be in the actual product recommendations feature for the first version. So that's more search, but there could also be visual recommendations, right? You could do products that are similar based on like in fashion patterns, those sort of things, or a complete the look type visual recommendation. But that won't be in the first version of what we release. All right, thanks everybody for your time.